our topology. All right. Now this chapter, which is the last official chapter of ICND1, the last official chapter of ICND1, we're going to take the information from this chapter and we're going to do a joint configuration exercise. And in this chapter, we're going to be configuring the routing information protocol. So for those of you that are actually following along and doing the lab exercise, pull up the file that we've been working on with the 2 routers and the 4 switches and the 4 PCs. And the way that I do this configuration is I kind of go through with the students and I have them execute the commands. And then we have a discussion about why we executed those particular commands. All right, so it's kind of almost like a paint by numbers chapter where we're just basically kind of going step by step through the exercise together and discussing the reasons why we did something and so on. So the first step, of course, is for you guys to go ahead and execute these commands, all right, on router 1 and router 2. All right. Don't go beyond this slide. Don't move on to the next slide. Just simply take a couple of minutes to execute these 4 commands. Well, 3 on one router and 4 on the other. And then let's have a discussion as to what these commands do and why it is that I'm doing these particular commands. You didn't get to eat your lunch?
No, I stay late, so I don't eat that.
Oh, okay.
Or else I call home and my wife wants me to get the sun and I don't get time stuff.
Yeah. They're bringing out the snowblowers. The heck does that mean? You guys supposed to be getting snow pretty soon?
I don't think so.
Usually it doesn't come till the new year, right?
You could get an early dusting in October, but yeah, you normally don't really get anything till November, and that's usually just a light one.
Oh, okay.
I'm lucky to get that.
Yeah.
Yeah, nowadays. When I lived in Maryland as a kid, though, in PG County, we have snow 3-4 times every year, and ponds would freeze over, you know, for a couple weeks and then thaw out and they'd freeze over. So, but nowadays, no.
Give me a quick what when you're done. Yeah. What? All right. So, obviously in this particular chapter, our goal is to configure and verify dynamic routing through the process of RIP. And so what we have to do is we have to talk about the steps that were necessary for us to configure RIP. We're going to talk about how to troubleshoot it, some of the caveats to RIP, and so on. As you can see, the very first command that we executed was router RIP. And then you'll notice that the prompt changes to config-router. Now at this point, RIP is not actually running. Router RIP is how we go into the configuration mode for RIP. And in fact, we're going to see the same thing with OSPF. We're going to see the same thing with BGP. We're going to see the same thing with EIGRP. Okay? In fact, you see the same thing, or at least a very similar thing with IPv6 as well. So by typing router RIP, you're basically going into the routing configuration mode, but you haven't actually implemented the routing protocol. The next step, which is common to all forms of IPv4 routing processes, ISIS, BGP, OSPF, EIGRP, is to implement these things called network statements. Okay? Now think about this for a second. The ultimate goal of a routing protocol is to do what? The ultimate goal of a routing protocol is to allow an R topology, router 1, to share routing information with router number 2. Do you guys agree with that?
Yeah.
Okay, we want router 1 to be able to advertise to router number 2 what it knows, and we want router number 2 to be able to advertise to router 1 what it knows. So, that being said, you would certainly make the assumption that the serial link between the routers has to run a routing protocol, doesn't it? You guys agree with that?
Yeah.
Okay. But the network statement in all instances of routing, whether it's OSPF, EIGRP, or RIP, the network statement actually does two things. All right? And this is a very, very important concept to understand. We don't care about RIP, right? In fact, RIP is pretty much a useless routing protocol because of its metric. However, in this topology, RIP actually works very well because we don't have redundant paths. But RIP is also good to get the foundation understanding of what these statements do and why we need to put these statements in, because the configuration process is very similar for every routing protocol. So as I was saying, the network statement does two things. It tells the router which interface to run the routing protocol on. Okay? So by having a network statement of 209.165.200.0, we're telling the router to run RIP on that serial link. That's the first thing that happens. Again, I want to say this again because I want to make it very clear. There are two things that a network statement does for a routing protocol. Number one, it tells the router which interface to run the protocol on. So it obviously makes a little bit of sense why we would have a network statement for the 209 subnet. Do I actually need to run RIP on the Ethernet segments? Again, what is the purpose of RIP? To exchange routing information with other routers, right? So those Ethernet statements or those Ethernet segments don't actually have any routers. So you might be wondering then, why did I put a network statement for those Ethernet segments if there's nobody on those Ethernet segments to exchange routing information with? Which brings us to the second thing that a network statement does. Unless, and I'll say this a couple of times, but because again, I want to make it very clear, unless the routing protocol is running on an interface, the network that's attached to that interface will not be advertised within the routing protocol. Unless the network statement includes the interface. The interfaces that are not included will not be advertised into the routing protocol. So if I did not put network statements for my Ethernet networks, then RIP would not be advertising those Ethernet networks. You guys understand the difference, right? I have to run RIP on the serial link because I'm trying to exchange routes with another router on that serial link. I have to run RIP on my Ethernet networks because if I didn't, then the networks would not be advertised. Okay? All right. Now, the other thing that might look a little bit strange here is the fact that we only did 2 network statements on one router and we did 3 network statements on the other router. Well, there's a very simple explanation for that. Network statements in RIP are entered in classfully. Classfully. So, the 10.0.0.0 network statement covers both Ethernet networks. The 10.0.0.0 network statement covers both Ethernet networks because 10 is a Class A address, and the only octet I care about in that case is the first octet because it is Class A. The 2 networks on the left are Class C. So I have to include both networks in my network statements because I cannot put in anything but a classful network statement in RIP. All right? Which is why, by the way, we put a 209.165.200.0 instead of 209.165.200.224. Because 224 is actually the network ID, but 209 is a Class C address. So we went ahead and just put in the corresponding Class C network for that 209 subnet. By the way, we're fully converged now. That's how simple it is to implement RIP. Now, granted, it's not the best way. We're going to see that as we explore the rest of the chapter here. But we are fully converged now. The PCs on the left can ping the PCs on the right, and vice versa. No problem. Okay? So let's find out how we can verify this. The first command I want you guys to run on router 1, show IP route RIP. On router 2, show IP route RIP. And now we're going to start to investigate the routing tables. We're going to start to investigate the routing tables. And by the way, this is kind of how we do EIGRP. This is how we do OSPF. We go through the chapters as a group. Although granted, with EIGRP and OSPF, there's a lot more theory that we have to cover, but we will. Okay? Well, I can see that router 1 only has 1 route, and I can see that router 2 has 2 routes. One of the most common misconceptions for people that are starting to configure routing protocols initially is that they think that the routes that show up are a direct relation to how they entered the network statements. And that is absolutely, unequivocally not true. The network statements are a light switch. They simply turn on or turn off the protocol. It just so happens that these network statements correspond to what we put, these routes correspond to what we put in our network statements, but that is purely a coincidence. Okay? Why does the 209 network not show up in this list? We know we're running RIP on the 209 network. We must be running RIP on the 209 network. So why does the 209 network not show up under show IP route RIP? Anybody?
Because it's a direct connection.
It's a connected network. And connected networks have an administrative distance of 0. RIP routes have an administrative distance of 120. So the connected route takes precedence over the RIP route. If you were to do a show IP route connected, of course, you would see, you don't have to do that, but you would see the 209 subnet. All right? So R obviously indicates how the route was learned. This is a route that was learned through the RIP routing process. 10.0.0.0/8 is the destination network. We're going to talk about why we're not seeing 10.1.1.0 and 10.1.2.0 in a minute. But look at what's in the brackets. Now we get to start understanding what goes in those brackets. The first number, administrative distance. Remember that? 120 is the administrative distance of RIP. Now you guys had a question on your first exam that said, of these below something, something, which one's going to be 90, right? And there was a D. Now you know what that means. D stands for dual, which is EIGRP, and 90 is the administrative distance for EIGRP. Show IP route RIP gives me nothing blank. Okay, Bernard? If you have nothing, then I would most likely surmise that either your interfaces are not operational or you fat-fingered a network statement. There's only a couple of things that can cause these routes to not show up. And that's if router 1 and router 2 are not talking to each other. So you need to do a show IP interface brief and make sure that your interfaces are up. Oh, sorry, Gio. I thought it was Bernard. You don't have to paste the config. Just go into each router and do a show IP interface brief. Make sure that the IP addresses on your interfaces are correct, and make sure that the interfaces are operational. That's step number 1. Make sure that the interfaces are up and running, and make sure that the IP addresses are correct. Also, verify that the subnet masks on the interfaces are correct as well, because the serial link has a different subnet mask than the Ethernet links. All right? I mean, as far as the configuration, I'm assuming, Gio, that you have the ability to be able to copy the config from the book. So I'm going to go ahead and assume that your RIP configuration is correct, unless you accidentally fat-fingered a number. So most likely, I'm guessing that your serial link is probably not up. Or you might have the wrong subnet mask on the link, or you forgot to do a no shutdown or something like that on one of your interfaces. Everything is up. Okay? Well, let's take a look. I'm going to make you the presenter, Gio, and I want you to share your screen so everybody can see it. Nothing but porn. All right, I see that your router 1, router 2, you got 192.168.10.1, it's up, 192.168.11.1, that is up, 209.165, 200, 225, up. On the right, 10.1.1.1, 10.1.2.1, 2, is that a 209? That doesn't look like a 209 to me. On the right side. It's a little small, so I can't read it, but is that a 209.165? Go up to options real quick at the top of the screen. Go up to options, the top of your screen. At the top of the screen, options in the toolbar. Left, 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 options, you just went over it. You see the little floppy disk?
above the yellow toolbar. Yep.
That's me, I can't click. Click options, Geo, options. Options in the toolbar. Go pretend like you're gonna go save your file. There's options to the next where you hit file.
Upper left.
Right below where you were.
Mi senti Giovanni? Prova,
Sorry.
vai su opzioni. I'm trying to tell Giovanni in Italian.
Oh, okay. Well, I can read it on my screen. I just couldn't read it on the projector. So I'm seeing it on the screen here. 209, 165, 200, 226. So let's go ahead and do a show run on router number 1. I was trying to read it on the projector and it wasn't as clear. So it does look like you have the appropriate IP addresses. Let's see if you have the right subnet masks. Those look good. So space bar. I see your problem. Hopefully you see the problem as well.
The network statement.
Yes. The middle network is not 192, it's 209. Where did you get 192, 165 from? Do you see it, Gio? Let's check the right side as well. On router 2, do a show run. Unfortunately, the grep commands in Packet Tracer don't work. So the right router looks correct. 209.165. So you just replace the 192 with the 209. Probably just do router rip and then take out that other statement by putting a no in front of it. And then you'll be good to go. All right. All right. Now you should see your routes if you do a show IP route rip. There you go. Excellent. So I'm going to take the ball back. All right. Now, as I was saying before, what is the issue that we have? Why am I not seeing the actual subnets? Well, it appears as though I see the subnets. Absolutely, Chris. Absolutely. That's why I don't want those people to fix their problem independently. I like to share them with the group because you guys just saw exactly what I would have done if this was my network. I want to make sure my interfaces are up and running first, right? Once I've verified that my interfaces are up and running and they have the correct IP addresses, there isn't a whole lot else that can cause an issue in this case, all right? Now, I guess the next question is, why do I only see one route on router 1, but I see both subnets on router 2? Kind of a rhetorical question, but maybe one of you guys know.
You see both networks from the other router.
I see 2 networks on router 2 from router 1, but I only see one network on router 1 from router 2.
That's good. You're looking at, because it's a Class A address,
Right.
all of them are, what do I want to call it? All of them are shown because of the network mask.
That is true. Because the 10 network has a mask of /8, it does include those two subnets. That's what we call summarization, isn't it? Although it's a very, very bad form of summarization because it includes every single 10 network that could possibly exist. Well, let me put you guys out of your misery, because when you implement RIP on a Cisco router, I want you guys to run on router 1. You don't have to do this on both routers, but on router 1, I want you to run the command show IP protocols. Show IP protocols. Now, show IP protocols is it's like show IP interface brief. It's one of those commands that we use all the time. It's not specific to RIP. It allows me to verify any routing process. And I can see from this output that I'm running RIP. Sure enough, I'm sending out updates every 30 seconds. The next update in my case is due in 12 seconds. But look at the versions. Under version control window, it says, I'm sending version 1. What is one of the major characteristics of RIP version 1? It is class full. The subnet masks are assumed, which means that RIP version 1 will only advertise the classful version of any network. Now, it so happens that the two networks on the left are already classful. They're Class C networks. So the fact that they're both being advertised just happens to be a coincidence because they're already classful. Whereas the two networks on the right are subnets. All right? The fact that we're seeing 10.0.0.0/8 has nothing to do with the network statement that we put in. It has to do with the fact that RIP by default is version 1, which means that we're sending only the classful advertisements, which is a bad, bad thing. All right? Also notice right below the section that talks about the version, there's a line that says, automatic network summarization is in effect. Meaning that whoever wrote this protocol decided that even if the protocol was classless, we were going to make it look classful. What does maximum paths 4 represent? Any ideas? I don't expect you guys to know the answer to this, but any ideas? We're going to see this show up over and over again. What does maximum paths 4 represent? It's the number of paths that a router will load balance over if it has equal cost metrics. So if I had 6 paths with the same metric to the same destination, only 4 of those paths would be load balanced. Does that make sense? That is the default for IPv4, up to 4 paths by default. And then routing for networks is essentially how I entered in my network statements. I'm routing for the 10 network, I'm routing for the 11 network, and I'm routing for the 200 network. And then the gateway is my neighbor. 226 is the neighbor to router 1. Okay? So obviously we don't want to run RIP version 1 because RIP version 1 is classful. So let's go ahead and, oh, there's a debug. I don't want you guys to run this debug, but I do want to take a look at it so you guys can understand what it's saying. Debug IP RIP will show you, I mean, you can run it if you want, but it's not really necessary. Debug IP RIP shows you the RIP updates as they happen in real time. Now, the reason I put this in here is because I wanted to show you, it tells me the version number. Sending version 1, look at the address that the update is going to. 255, 255, 255, 255. Which is what we'd expect, right? Now, if we were running RIP version 2, we would see a multicast address there, not a broadcast address. All right? Also notice that updates are not only being sent out of the serial link, but updates are also being sent out of the Ethernet links. You see that? Why on earth would I ever have to send updates out the Ethernet link? There's nobody there to hear them. So that's a bit of a security risk, not to mention it's a waste of a bunch of resources. Sending updates out the Ethernet links is a waste of a bunch of resources. All right? So let's go ahead and switch to RIP version 2. Just the first two boxes I want you to run. Just the first two boxes. We'll do the troubleshooting together.
On both routers, right?
Yep.
Just a question.
Yes, sir.
After I hit end on, from the configure terminal, it always comes up with that sys5 config.
It's just a
entity.
syslog message telling you that the configuration has been modified. So if you're actually trapping those messages and you're monitoring whether or not your configs are changing, that message will tell you whether or not the configs are being changed.
So is it default for that to show up, or is it
Yes.
something you have to?
It's default for that to show up if you're on the console,
Okay.
not if you're telnetted. If you're telnetted, you have to do term mon.
And what if you're directly?
That is,
Oh, yeah,
console
yeah,
is
right.
where that comes from. I think it's pretty clear what these commands do, isn't it? I have to have the AC on because I'll fall asleep up here if I'm not. Remember, I'm the one talking the whole time. It just kicked off though, so. It's only at 67, come on. No, 71. Obviously, we know what the goal of this command is, to switch from RIP version 1 to RIP version 2. And if you do a show IP protocols, you will see that you are now running RIP version 2. However, if you do a show IP route RIP, we still don't see the networks. Give me 1 second here, guys. This is a very important call. Hello? Hey, Jeff. Hey. Yes, sir.
What's that?
It's show IP RIP database.
test for this, for the ICND two, right?
Yeah, I think it's gonna be one of those, you can take it on your own, because we're not doing it, normally you would do it here. Like he said, he has his own, like, laptops when I took the class like 4 years ago. Everybody had their laptops and he was the actual proctor and they did it in-house. But since we have to go to another facility, I figured, since we've been going over anyway, I figured he'll just keep instructing until Saturday, until Friday. But you're here for the weekend, so you might be able to take it whenever. I'm probably just gonna take mine like on Monday or Tuesday or something. Maybe on Saturday or Sunday, I don't know. I always got stuff.
And that facility, I'm not sure when they open, but they might open before class starts.
There you go, you can take it. You'd be the only one here though.
And,
I guess the
well,
guys online too.
there might be other people that have signed up for it,
Usually
that already have CCNA.
this is true.
Because I think you can take a test for that and get another certification. I'm not sure.
No, there is a test for it.
Oh, is there?
Yeah.
Because I know my company said, well, hey, he's here, you're gonna be there anyway, just take that class.
I'm gonna wait to take it because you taking it like 3 years from now, you recertify your CCNA as well. But like you said, your company's already paying for it. Like, I'm not. I'd have to pay for it out of pocket, so it's good. So that's my ration.
Which, 2 days for the security class. That's a lot of information in 2 days.
You figure we're doing CCND 2 days, Thursday, Friday.
I know, see, that's why I told my company, hey, I want to take this class, it's down the street here. It's 1 week for ICND 1 and 1 week for ICND 2. Just because I know how I learn. And they said, well, we already got a partnership with this guy.
He's good, man.
And since they're paying for it, I was like, oh, okay.
You might find that instructor or their process not as good as it. This guy's pretty good. Like, I've gone to other classes.
When it comes for getting study materials and how he has you study and what his objective is at the end of like teaching this, it is different than them. Their end objective is not to get you to pass the exam, but it's to give you information, all the information, so then you can go and take an exam, not to get you to actually pass it. Right, so, which, that's not their scope. Their scope is just to provide all the information and instruct you on it. That's it.
I got you.
Because I took the Security Plus class with them. There was no real, I mean, there were study materials, but it's different than his classes here.
Did you pass it?
No. There were so many questions in their study material, which, I mean, they're all possibilities.
Right.
But there was no way I could go to class, drive to and from, and then
Having the time to study.
memorize all that stuff at night in a week.
Right.
Because it was strictly memorization from what the study materials they give you. And it was like,
When I took it,
I don't even know how many.
it was definition based.
Mm-hmm.
All the questions were definition based. There was no scenarios and nothing. It was all definition based. I don't know if they changed it, but I took mine like 2009 or something like that.
I think if I took a Security Plus class with him, I would pass the test. Although
Or
there,
you don't have security plus?
no, I didn't pass it.
You don't need it now, to be,
Not with what I do now. If I wanted to get a government IT job, then you have to have it.
no. The security portion of CCNA takes care of that criteria. If you-
Oh, really?
Yeah. So it's a good thing for you then.
I better buckle down this
Yeah.
weekend then, right? Because then I can always, now I open myself up to about another 30% of the job market out there.
You do. Government in this area is like, it's ridiculous.
Sorry about that, guys. That was important call. All right. So the question that I posed before I walked out was, why am I still seeing the 10.0.0.0/8? If we know we're running classless routing now, and RIP is not running as a RIP version 1, we can clearly see it's running as RIP version 2. Why am I still seeing 10.0.0.0/8? Does anybody have any idea?
Well, you're still sharing information back and forth between the two routers, and it's the other router that has those subnets on.
Yes, that's true.
So it's gonna advertise, hey, here's what I know, bang.
Right.
And the guy's getting.
But it should be advertising 10.1.1.0 and 10.1.2.0.
But that's not what we added into the.
The network statement has nothing to do with how routes are advertised. I already said that. The network statement does not define how networks are advertised. All the network statement does is turn on or turn off the protocol on interfaces. Okay? So just because we entered a network statement in as 10.0.0.0 does not mean the networks are going to be advertised as 10.0.0.0. Very important concept to understand. And a lot of people think that way. A lot of people think that the way that you enter the network statements defines how the networks get advertised. What defines how networks get advertised is what is actually configured on the physical interfaces. But there is obviously a reason why we're still not seeing the subnets. And the reason is on this screen, right towards the bottom. Big hint. What is it?
Automatic network summarization.
Automatic network summarization is in effect, meaning that even though RIP version 2 is classless, its default mode is to act classfully. This used to be what the EIGRP did as well. EIGRP used to do this, but it doesn't do it anymore, right? Cisco got rid of that quote-unquote feature. Well, we need to turn that off because I want to see the subnets. We've got to turn that off. So I need to go in to my RIP routing process and get rid of that automatic network summarization. I'll use the no auto-summary command to do that. No auto-summary. Hola, Chantel. No auto-summary. Now, of course, if you do a show IP protocols now, you'll see that automatic network summarization is not in effect. And if you do a show IP route RIP, you'll see that the subnets now show up. Of course, that other one is still there. It'll go away eventually. RIP kind of keeps routes around for about 240 seconds. It's called a hold down timer. Got it? So no auto dash summary turns off automatic network summarization. I don't know of any instance where you would ever actually want to run automatic network summarization. It's just about the dumbest thing that you can have running in a modern network today. It didn't affect us in this topology. It did not affect us in this topology because we only had one path and the 10 networks only existed in one location. But if those 10 networks existed in other locations, we would have all kinds of routing problems. Okay?
You said the classful entry will eventually.
Yeah, eventually it goes away. It's in what we call a hold down state. RIP is such a dumb protocol that it says, you know what, this network isn't being advertised anymore, but it might come back. So I'm just going to wait about 240 seconds to see if it comes back or not. Okay? All right. Cruising along here.
And will it also go away on router 2?
Router 2 is not going to change, right? Because router 2, I was already receiving the appropriate networks.
But it also, on router 2, it also shows that 10.0.0/8.
Well, it shouldn't.
Says is variably subnetted.
Well, those are connected. Are you doing a show IP route RIP?
Yeah. It doesn't have a code next to it. It's the first line that comes up. Which comes up the same.
Yeah. Well, I definitely know why it's showing up on the left. It shouldn't be showing up on the right, though. I don't know why it's showing up on that router.
Well, on the left, it has the same statement, but it also has, it has this.
Right, but
it's
that
gonna
should
go away.
That should say 192.168. Yeah, I'm not sure why that's showing up on that router on the right. It shouldn't be showing up on the router on the right. There is no 10 network in the RIP process on the router on the right. They're in the connected route. They're connected, so must be a bug in Packet Tracer. Excuse me. This is what it should look like, right? No, it does show up here too. It's weird. That's definitely a bug in Packet Tracer. It shouldn't be there. All right. The only thing that should show up under show IP route RIP are routes that have an R next to them. That's actually not even a route. That's just a category. So that's definitely a bug in Packet Tracer. Notice it doesn't show up on the other router. So I never noticed that before, but that should definitely not be there. Okay? Now, the other thing to keep in mind, and we mentioned this before, is we're still sending routing updates out of our Ethernet interfaces. Is there any reason that we should be sending routing updates out of our Ethernet interfaces? No, there is no reason. There's nobody on those Ethernet networks that need to hear anything. Nobody's on those Ethernet networks that needs to hear RIP updates. So you might say, well, I'm just going to go ahead and take the network statements out for those networks. But if you do that, then the networks don't get advertised. So there's another command that you have to know, which is part of actually all of our routing protocols. OSPF has this, EIGRP has this, and RIP has this. It's called passive interface.
Yeah, right. Something interesting, because on router 1, it hasn't taken that statement out yet, but it's been enough time that it's telling you, oh, it's possibly down.
Right.
Letting you know.
Yeah.
Which is interesting.
Yeah, RIP is kind of going through these macronations, right? There is no need to send updates every 30 seconds out the Ethernet interfaces. So we're going to do something called making those interfaces passive. When you make an interface passive in any routing protocol, it essentially suppresses that routing protocol from running on that interface. But it still allows that network to be advertised. All right, now there's two ways to do passive interface. You can make all of the interfaces passive and then make some of them not passive. That's what we see in the bottom box. Or you can just simply enter which interfaces are passive. That's in the top box. It doesn't matter which way you use, which method you use, right? The only difference between one or the other is what is more convenient for you. If you've got a bunch of router interfaces on your router, and all of those, let's say you've got 50 interfaces on your router and 40 of them are passive, then go ahead and use the bottom option. Make all the interfaces passive, and then just make the 10 that are not passive, not passive. Does that make sense? If you only have a couple of interfaces on the router that are passive, then just enter those in individually. All right? In our case, we don't actually save anything either way. It's 2 commands to make the 2 Ethernet interfaces passive, and it's 2 commands to make passive interface default, and then to make some interfaces not passive. All right? Passive interface works on all routing protocols, all of my IGP routing protocols. It's the exact same command syntax for OSPF, for EIGRP, for RIP, passive-interface under the routing process. Okay? How can I verify that I've made an interface passive? Show IP protocols. When I run the show IP protocols command, it will tell me which interfaces are passive. In this particular case, I can see that gigabit Ethernet 0/0 and gigabit Ethernet 0/1 are passive. And that is officially the end of ICND 1, even though we did cover some material for ICND 2. That is officially the end of ICND 1.